Hello, everyone. So today I have the recording for the upcoming test, test number 4. Once again, it should just be attached to the announcement. This should go up ahead of time. I'm trying to upload it by Wednesday night, hopefully midday Wednesday, because I am leaving. So hopefully it is up by then. But make sure it is only 11 questions on this test review, so make sure you're going through all of them. It is most likely that every question on this review is going to be on the test, so definitely just look through them all, make sure you can do them, change the numbers, repeat them, and definitely look back at your worksheets for the same examples that we have on the test review and review them in your worksheet. That's probably the best ways to study for the test. All right, so let's just hop right into number 1. So it says use the vertex and intercepts to sketch the graph of the quadratic function y plus 1 is equal to x minus 3 squared. All right, so the first thing that we're going to do right here is we're going to get y alone. You can't really graph anything when y is not on its own. So I'm just going to minus 1 from both sides. So we get y is equal to x minus 3 squared minus 1. And then now we're just going to use our knowledge of how like graphs shift based on what they look like from their base to what they are. So we know that the graph x squared, or you could say y equals x squared, has its vertex at 0, 0. Well, looking at this graph inside the parentheses, that tells me that it is shifted to the right 3. Remember, it's always like what the opposite of what you think when it's inside the parentheses. So if it's negative, it goes to the right. If it's positive, it goes to the left. And then the 1 on the outside right here, a minus 1, that tells me it's going to be going down 1. So if it's going to the right 3 and down 1, that's going to tell me that its vertex is at the point 3 comma negative 1. That is our vertex. The next thing you want is your x-intercept. So I can solve for those right here. And how you get your x-intercepts is you just plug in 0 for y and then solve for x. So we'll say 0 is equal to parentheses x minus 3 squared minus 1. Add back that 1 over. So we get 1 is equal to x minus 3 squared. To get rid of the square, we're going to take the square root of both sides. This is where you have to be super careful, though. It's not just going to be 1 on this side. Since we're taking the square root, it is plus or minus 1. Whenever you take the square root of something and you're solving for x, make sure you put plus or minus. On this side, it is just going to be x minus 3. So then we'll break it apart. We'll say 1 is equal to 1 equals x minus 3. And the other one will be negative 1 equals x minus 3. So if we add 3 on both sides for both, we get x is equal to 4 and x is equal to 2. So those are our two zeros. So you could also say that that means that they have a point on the graph 4 comma 0 and 2 comma 0. And then last up is our y-intercept. So instead of plugging in 0 for y, we're going to plug in 0 for x. So y equals parentheses 0 minus 3 squared minus 1. So that's going to give us y is equal to a negative 3 squared minus 1. Y is equal to 9 minus 1. So y is equal to 8. Or you could say that your x-intercept is, or you're not your x-intercept, your y-intercept is then 0 comma 8. So now we have 4 points that we can graph. We have 3 comma negative 1, 4 comma 0, 2 comma 0, and 0 comma 8. Other things that you could identify to help you graph this is using some of those later things that we learned where, so this is going to be a positive x squared graph because we have our x squared here. And then this leading coefficient is positive. So you could add on the side, although it should be pretty obvious with what we have here is it's going to be rising to the left and right because it's a degree 2 or even. And it is positive. So it should be ending up. So I'll just sketch right here what your graph should look like. But once you have the points, it should be fairly simple to graph from there. So the first point we need is -1, 3. That'll be right there. We need the points, 2, 0, and 4, 0. And then 1, 2, 3, 4, 5, 6, 7, 8. That right there. And then that will be your graph. Something that looks kind of like this. One thing you could also add there, if you'd like, is an axis of symmetry. It goes right down the middle, and that line is going to be not y. It's going to be x equals 3. So your axis of symmetry for this equation is x equals 3. And that really covers it. So for any of these questions, when it's asking you to graph a quadratic formula, the 3 things that you're looking for is the vertex, the x-intercepts, and the y-intercepts. So those are the 3 things that you're like, okay, that's what I got to find. Once you have those, you can hop over to the graph. For number 2, it's fairly similar, except we have a little bit of a different graph. It's asking us to graph f of x is equal to -x squared minus 4x plus 5. So it's in a little bit of a different format, but we can still find the same stuff that we're looking for. So the first thing that I'm going to look for is my vertex. And how we do it when it's not in a format where we can kind of see the transformations is we're going to use that vertex formula. So x equals -b over 2a. So in this case, my b is equal to a -4. So that's going to be a -4 on top. And my a is equal to -1. So it should be 2 parentheses -1. This ends up equaling 4 over -2, which ends up equaling -2. And then to find your y value, well, we'll just plug it into our f of x. So we could say f of -2 is equal to a -2 squared minus 4 parentheses -2 plus 5. Solving some things down, we get -4 plus 8 plus 5, which equals 9. So that tells us that our vertex is -2, 9. And how can you tell if this is a maximum or a minimum? Well, kind of what I discussed on the last one, you can use some of those ideas of even and odd functions. So we're looking at that leading, where the highest degree in it is 2. So that tells me that it's going in the same direction at the ends. So it's either both going up or both going down. And then since it's a negative function, we know that it's going down. So our ends of our graphs are going to look like that. All right, next up is our x-intercepts. So we're going to equal this to 0. So 0 is equal to -x squared minus 4x plus 5. One thing that you could do to make this a little bit simpler for you, maybe you don't like this -x squared in the front. We can actually pull out a -1. So we can say this is 0 is equal to -1 parentheses x squared plus 4x minus 5. And then what's this? If you can't see it right away, you can do this thing on the side. So we're looking for a number that multiplies to -5 that adds to +4. Trying to think off the top of my head, that's going to be 5 and -1. So breaking it up, we get -1 parentheses x squared. I'll say plus 5x minus x minus 5. And then factoring both sides, pulling out an x on this side and a -1 from that one. So what I just did, I did x parentheses x plus 5 and then -1 parentheses x plus 5, just so I can show the work. And then obviously they both leave x plus 5. And then now we just equal both of them to 0. So pencil not working, not like in this section. X minus 1 equals 0. So there it means x is equal to 1. X plus 5 equals 0. That means x is equal to -5. So then once you, again, you could say that your points are 1, 0 and -5, 0. All right, and then next up is our y-intercept. And that one, you're just going to be plugging in 0 for x. So y is equal to -0 squared minus 4 parentheses 0 plus 5. Well, obviously that cancels, you're just left with y equals 5. Or you could say your y-intercept is 0, 5. So once again, we have those 4 points. We have a y-intercept, we have 2 x-intercepts, and we also have our vertex. So we can go to graphing. The first point I need is -2, 9. So that's going to be somewhere. Oh, I went the wrong way. 1, 2, 3. Somewhere about here, -2, 9. Keep drawing some lines. Next, I'll do my 2 x-intercepts. So 1, 0 is right there. -5, 0 is right there. And then my y-intercept of 0, 5. Right about there. And that is your one for that one. And then once again, if you wanted to draw that x-axis, or not x-axis, axis of symmetry, that's going to be the line x equals -2. So once again, you can see we did the same thing. We got our y-intercept, x-intercept, and vertex. And then we got our points, threw it on the graph, and got our answer. For number 3, we get a little bit of an application problem. So it says the manufacturer of a smartwatch has found that the revenue R in dollars is R of P is equal to -5P squared plus 1,210P when the unit price is P dollars. If the manufacturer sets the price P to maximize revenue, what is the maximum revenue to the nearest whole dollar? So whenever you see something like this and it says maximize or minimize, you're looking for the vertex. You're looking for that turning point in the graph where it is at its highest for its maximum or when it's at its lowest for its minimum. So the first thing to do is to find its x, or to find its vertex. So I'm just going to write the function here. Ooh, still using a highlighter. There we go. R of P is equal to -5P squared plus 1210P. If you remember from the last problem, our vertex formula is x equals -b over 2a. So in this case, our b is 1,210 and our a is -5. So then we get -1,210 over -10. And that simplifies to 121. So basically that is saying that I put an x here, but if I wanted to actually be really exact, it should really be a p because there are no x's in our formula. So that's saying at the price 121, our profit is at its maximum. It's at its highest. But they weren't looking for that value. They want to know how much they're going to make. So we got to plug it into our original. So we're going to say, or we're going to find R of 121. It is not liking my pencil. There we go. That's going to equal -5, parentheses 121 squared plus 120 or 1,210. Plugging that into your calculator, I already have the answer provided for me. That's going to get you 73,205. So make sure when you have some type of word problem, make sure you include the $sign. We want to be exact. And then also make sure you're solving for the correct thing, because some people might think, oh, I found a number from doing math. So you'd think 121 is your answer, but just realize that it's asking for the total revenue. So they're not just asking for the unit price, which was the value we got here. They're asking you to plug it back in and get the total amount. So that is number 3. For number 4, it is pretty cut and dry. It is just saying determine whether the function is a polynomial function. So f of x is equal to 15x raised to the 7/5 minus 5x plus 7/x. So some things that are red flags for me in this one is this 7/5 here and this over x. So in polynomial functions, you can't have fractions as exponents. So that's one thing that's a no-no. So no. And then also this over x, you can't have them in the denominator. So that's also a no. Some other things that you can't have is them under the square root, which is actually something we already just talked about, because you can actually write the square root as x raised to the 1/2. So that is a exponent as a fraction. So that's the same no. And then over here, we can't have negative exponents. So we don't want -1, -2, any negative exponents. That makes it not a polynomial function. But then same thing happens here. X to the -1 is actually the same as 1/x. So we have the same thing happening there as well. So the 4 things you're looking for to determine if it's a polynomial function or not: if there's fractional exponents, if there's x's in the denominator, if they're under a square root, or if their exponent is negative. So those are the 4 things. And that is it for number 4. So it is not a polynomial function. For number 5, it is asking you to find the x-intercepts of the polynomial function and also to state whether the graph crosses the x-axis or touches the x-axis and turns around at each intercept. And our equation for this is f of x is equal to x to the 4th minus 144x squared. So the first thing I'm going to do for this one is I'm going to pull out what they both have in common, which ends up being an x squared. So I get x squared, parentheses, x squared minus 144. All right, and then the next thing I could do is that I could see that this is a perfect square or difference of perfect squares. So I can actually factor this using the method of difference of perfect squares. So I get x squared, parentheses, x plus 12, x minus 12. There might be a lot of factoring on this test, so be aware of that. Algebra is a lot of factoring. So I might throw at the end of this test some of the quick factoring ones that might be good to remember that I've seen pop up. So check that out probably at the end of the video. All right, but we have it here. We have it as simple as it could get. So now we're just going to equal each of our factors to 0. So that's something that I should have done at the beginning, which I did not do, is equal this to 0. So we get x squared is equal to 0. And that just is x is equal to 0. X plus 12 is equal to 0. Is x equals negative 12. And then x minus 12 equals 0 is x equals 12. So those are our zeros, 0, negative 12, and 12. But then we also have to remember that it's asking us if they cross the x-axis or touch and turn around at the x-axis. And how you determine when it does that is by its multiplicity. So we look here, our x squared has a multiplicity of 2. or you could say our x has a multiplicity of 2. And then our x plus 12 and our x minus 12 both have a multiplicity of 1. So when it's an even multiplicity, it touches and turns around. So I'm just going to write the word turns for short. And then whenever it's an odd, it crosses. So I'll just write cross. So if you want the short of what's in my head, and what I used to remember is even turns and then odd crosses. So how you write this answer for this is you'd say x equals 0, touch and turns, x equals negative 12, comma 12, crosses. Obviously, you don't have to write it exactly like this. You don't need the semicolon. Maybe you say touches and turns, but as long as it has the same concept that you're showing, that the one with the 2 multiplicity touches and turns and doesn't cross, and that the ones with the single multiplicity do cross, that will get you the right answer on this question. For number 6, it's pretty similar to number 4. It's pretty short, just kind of having you remember some of those definitions that you learned. So it's saying using the leading coefficient test, use the leading coefficient test to determine the end behavior of the polynomial function. And our function is f of x is equal to x plus 5x squared minus 4x squared. Kind of wrote it poorly, my bad. But really all you're looking for is find the aspect of this function with the highest degree. So that's going to be your, right at the end here, your minus 4x squared, not 4x squared, your minus 4x to the 4th. That is really the only thing you're looking at. So the first thing we're going to look at is its sign. Is it positive or negative? Well, it is negative. And then you're also going to look at the power. So the power of our largest aspect is to the 4th, which is an even number. So with even, that means that it goes in the same direction. So it's either going to be both up or both down. And then with your negative, that means that it goes down, or it's ending. So what it should end with is that it goes down, no matter what. If it's an even function or an odd function, or if its leading coefficient is even or odd, it will always end down. So that tells you it has to be this one, that they are both going down. So it could be something like this, or since it's x to the 4th, it's probably going to look something like that. So what they're looking for you to say here is that it falls. What is its ending behavior to the left and to the right? Well, as we can see here for both of these, it falls to the left and also falls right. One thing I just want to throw in there, because some people do forget, if you're looking at something that's leading with like x to the 3rd, maybe x to the 3rd is your greatest one, the base of that graph usually looks like this. So you can tell, okay, this is at its base form when it's a positive in front and an odd power, it falls to the left and rises right. So just make sure whenever it's odd, you should have 2 different directions. It should fall one way, it should rise the other way. And then if it's negative, if it's a negative coefficient in front here, so that's where you're looking there, that's where you're looking there. If it's negative, it falls to the right, no matter what. And that is number 6, using the leading coefficient test. For number 7, we're using what we just did with number 6 to actually graph a function. So we're graphing the polynomial function f of x is equal to x to the 4th plus 6x to the 3rd plus 9x squared. So the first thing you want to do with this is observe, what is it going to look like? What am I kind of getting a broad idea of what this is going to look like? So using that leading coefficient test, we're just going to be looking at our greatest power, which ends up being the first term, x to the fourth. So it is once again even and positive. So that means it's going to rise on both sides. It's going to end like that. Or if you want to get exactly technical, you could say it rises right, rises left. All right, and then the next aspect is finding your zeros. So we're just going to equal this function to 0. So x to the fourth plus 6x cubed plus 9x squared is equal to 0. First thing I'm going to do is pull out what they all have in common, which ends up being an x squared. So x squared parentheses x squared plus 6x plus 9. Now you can do the same thing again, where you look for something that multiplies the 9 that adds to 6. That ends up being 3 and 3. Another thing you could observe, which is another one of those factoring kind of tricks that I'm going to show you at the end, you can see that both this is a square and this is a square, and this equals 2 times AB, if you were to call this a squared and b squared. So it's going to end up being x squared parentheses x plus 3 squared. So if I factor it on this side, just to show you what I did. So I broke up that 6x into x squared plus 3x plus 9. Pulled out an x on this side. Pulled out a 3 on this side. So I got x plus 3, which ends up just being x plus 3 squared. And then now it's in simplest form, so I'm going to equal them both to 0. So I get x squared is equal to 0. That tells me once again x is equal to 0. And this one, x plus 3 is equal to 0. So x is equal to -3. One thing you have to remember when graphing function is to look at the multiplicity. So they both are squared, which means that they have both an even multiplicity, which means they will just touch the x-axis. They won't actually cross it. All right, and then the last thing you might want to solve for to get to graphing is your y-intercept. So we'll just be plugging in 0 for x. So we get f of 0 is equal to 0 to the fourth plus 6, 0 cubed plus 9, 0 squared. Well, 0 to the fourth is 0, 0 to the third is 0, 0 squared is 0. So you end up getting just f of 0 equals 0, or that our y-intercept is the point 0, 0, which makes sense because one of our zeros is 0. And then that's one thing I forgot. You could say that our points here are 0, 0, and -3, 0. All right, now let's look at what that looks like on a graph. So we don't need that many points. All right, so I'm graphing 0, 0. I'm graphing -3, 0. It's got to rise both ways. So I'll start from left to right. So it's coming down since it's rising to the left. Since my -3 is a multiplicity of 2, it's just going to touch and kind of bounce off it. But then it has to come back down to get to this 0 here, which once again does the same thing. It bounces off my x equals 0, and then it will go up and look like that. So that is your graph for number 7. All right, for number 8, we get to long division with algebraic expressions. So it's saying divide using long division. And what we have to do is -20x cubed minus 13x squared plus 35x minus 10 divided by negative 5x plus 3. All right, so how we set that up is I'm going to put my negative 5x plus 3. I guess I'm writing red for this one. Kind of set it up like how normal long division used to look. And then we'll write the numerator on the inside. All right, so now what we're looking for is we're looking for some number that when multiplied by this, we get this, not the opposite. A lot of people think, oh, well, we're trying to get rid of it, so we have to have it opposite so that they cancel. When it's with long division, you're automatically subtracting it. So you actually want to get the same. So in this case, what we need to do to get negative 5x to turn into a negative 20x cubed is we just have to multiply it by 4x squared. So that will be you could write your minus negative 20x cubed. And then you also multiply it by the other ones. That's going to be plus 12x squared. And I got that 12x squared from doing 3 times 4x squared. All right, so as I wanted, my 20x cubes are going to cancel. This is really a negative 13x squared minus 12x cubed. So that's going to give me a negative 25x squared. And I'll just move everything else down. Plus 35x minus 10. Sorry for flipping colors, but it might help out to see it that way. So now we're looking for something that multiplies by negative 5x to get that negative 25x. Well, that's going to be a positive 5x. So multiplying both by positive 5x, that gets you that negative 25x squared. And then that other one's going to be a positive 15x. So I got that by doing 3 times 5x. Once again, as I wanted, my 25x squares canceled. And this is a 35x minus 15x. So that gets me 20x. And I'll bring down my negative 10. All right, and then for my last one, I'm looking for something that multiplies by negative 5x to get negative 20, or just 20. So this one ends up being negative because we want our negative 5x to be a positive 20x. So that means I have to multiply it by negative 4. So that'll give me a 20x on the inside. Negative 4 times 3 is a negative 12. So my 20x's cancel. And now I have negative 10x minus a negative 12, which kind of acts as a plus 12. So negative 10 plus 12 ends up being 2. So I have 2 as a remainder. So my answer for this, I can start running it out, is 4x squared plus 5x minus 4. But I can't leave out my remainder here. So we write that as 2 divided by what I was dividing by originally. So 2 divided by negative 5x plus 3. And that is your answer for this. 4x squared plus 5x minus 4 plus 2 over negative 5x plus 3. All right, for number 9, we're still dividing, but in this case, they want us to divide using synthetic division. So what we have is x to the 5th plus x squared minus 1 divided by x minus 2. I think synthetic division is a lot easier. As long as you know the format and the method, it just goes a lot smoother than doing long division. And then something you're going to see here that I forgot to mention in the long division one is that you have to make sure that you have placeholders for stuff that isn't there. So in this case, we're missing an x to the 4th, x to the 3rd, and an x. So you're going to end up putting zeros there. If we go back to the long division, if you maybe were missing your x squared here, you would have a negative 20x cubed, and then you would say like plus 0x squared. You just have to remember that x squared and make sure you're accounting for everything that's there if it's missing. So in this case, how you set it up is I usually draw something like this. There's a bunch of different ways that you could draw it. And then I'm going to put what I'm dividing by right here. So remember, it's the opposite of what this number is. So that's going to be, instead of -2, it will be 2. And then I'm just going to write out all the coefficients of my top or of my numerator. So x to the 5th is 1. We have no x to the 4th, so that's 0. We have no x to the 3rd, so that's 0. We do have our x squared, that's 1. We have no x, so that's also 0. And we have our 1, which is -1 at the end. All right, you bring down the first. So I'm going to put an arrow down to bring my -1 down. Then you just jug along. 2 times 1, that is 2. 0 plus 2 is 2. 2 plus 2 is 4. Or 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. So I put the 8 here. 1 plus 8 is 9. 2 plus 9 is 18. 0 plus 18 is 18. And then 2 times 18 is 36. -1 plus 36 is 35. And so remember, if we started with an x to the 5th here, we're losing one factor of x. So this is my x to the 4th coefficient. So for this one, you end up with x to the 4th plus 2x cubed plus 4x squared plus 9x plus 18. And then we have this 35 as a remainder, same way as it was with the long division. Whatever you were dividing by, you just put that under your remainder. So 35 divided by x minus 2. So that is your answer for number 9. Pretty quick. All right, here is number 10. This is kind of summing up everything that we've been doing from this unit, putting it all together. So it's saying solve the polynomial equation, x to the 3rd minus 7x plus 6 equals 0. And then part A is asking you to make a list of possible rational zeros. So what those are is you're going to take your last term and your first term, or I should really say, to be completely exact, the coefficient of your last term and the coefficient of your first term. So in this case, it would be 6 over 1. Now we want to write this as all the factors of 6 on the top and all the factors of 1 on the bottom. So what numbers multiply and are able to get to 6? And then you also have to remember for this that you have to take into account both positive and negative numbers. So for 6, it's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then 1 is pretty simple. That one is just plus or minus 1. And then we just have to now write out all of our possible factors. So it is pretty simple for this one since it's just 1. So obviously it'd be 1, -1, 2, -2, 3, -3, and 6, -6. If you were to go through the process and maybe divide, because really you could say that this is 1, -1, 2, -2, 3, -3, 6, -6, divided by 1, -1, you'd end up with, let's see, there's 8 on the top and 2 on the bottom. So there's 16 different numbers that you could get from this, but we only ended up with 8 because we had some repeats. If maybe you have a 2 in the front here and you end up having on the bottom 2, -2, I would highly recommend, it takes a little bit of time, but I would highly recommend going through the process and writing out every single one of these fractions, because you just want to make sure you're taking into account every single possibility that there is. A positive 3 over 2, a negative 3 over 2. Just make sure you're writing them all out to make sure you are getting them all and making sure that you have them all and all your possible zeros. But for this case, We got lucky and we just have a 1, -1 on the bottom. So these are our possible zeros. And the reason we do that is because we have to find one of the zeros. So it looks like the way that it might have been done in class is you plug it into your function, which is one way that you could do it. What I prefer to do is to do synthetic division because it's actually what you're going to do in part C. So it kind of gives you a head start. And it's something that we did learn in class. If you use synthetic division and you end up with a remainder of 0, that means that it is a factor of that equation, or it's one of your zeros. So I'm just going to take a guess. What you would do on a test, you kind of just go from left to right testing these. So I'm going to do synthetic division with 1. And so just so you can keep track on your own, this is part A, all right here. And then now down here, I'm going to start on part B, B/C, we could say, because it's going to be both of them. All right, so I'm going to do synthetic division with 1. And this one, you don't have to flip the sign because we are already just taking the 0. Although you could say if you do maybe mess up, well, 1 and -1 are both zeros or possible zeros. So you're not really making a mistake by putting 1 or -1 because the negative of those is just 1 and -1. Synthetic division with 1. I'm going to write my coefficients. My coefficient for x to the third is 1. I have no x squared, so that has to be 0. The x is -7, and then my last one is 6. Drop down, that gives me a 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -7 plus 1 is -6. 1 times -6 is -6. 6 minus 6 is 0. So I nailed it on the first one, which is good. What might happen is maybe you do get a remainder here. 1 doesn't work out, just move on to the next. Just keep going. Keep doing synthetic division until you get one that ends with 0. Because now we know that x minus 1 is one of my factors for this all the way up here. But then also we're left with something a little bit simpler. So if this started with x cubed, this is my coefficient for x squared. So we end up with x squared plus x minus 6. And this is something that I can factor. What is something that multiplies to -6 that adds to 1? Well, that's going to be 3 comma -2. So I can break this up as x plus 3 and x minus 2. Just so you can see that factoring out. Not a plus 6, a minus 6. So I broke up x into a plus 3x minus 2x, pulled out an x on this side to get x plus 3, pulled out a -2 to get also an x plus 3. So that got me the x plus 3, comma, x minus 2. So my completely factored form of this is going to be x plus 3, x minus 2. And we cannot forget the one up here, x minus 1. Oop. Whoa. X minus 1. And now we can get our solutions. So solving the polynomial, solving the resulting polynomial equation. So this was our resulting polynomial equation. So then solving this, we equal these both to 0. So x plus 3 equals 0. X minus 2 equals 0. So x equals -3. X equals 2. So that's your answer to D. And then for E, we can state our zeros. That's going to be -3, 2, and we cannot forget 1. And that's your answers to all of the parts for that one. A little bit confusing at times to get through it, but there is just some kind of process that you have to follow for that. This is your answer for C. This could be your answer for B, showing that synthetic division worked. And then A would be that list of numbers there. All right, and our last question of the review is number 11. I don't have the exact review in front of me, so there might be a little bit of words that I'm missing. But for number 11, it's saying n is equal to 3, and that your zeros are 3 and i's, so both i's. And then that also for the function f of 2, it is equal to 15. So it seems like a bunch of random information. Just so you know, when you see something that looks like this, it will be the same method. What this n equals 3 means is how many zeros you have, which also, I mean, doesn't really matter because they are telling us what our zeros are, 3 and both i's. So what does this mean? What do we do? Well, you can write out your factors. If 3 is a 0, that means that one of my factors has to be x minus 3. And then same thing applies to the i's. It'd have to be x plus I and x minus I. And then when you're doing something like this, we're not really sure. There could be a coefficient in the front, there may not. To symbolize that, we're going to put an A. Always remember this A at the front. And then that A will come in handy later. All right, so the first thing we're going to do is double distribute our second half here. So I'm going to double distribute it out. The whole point of this is to kind of get rid of those i's. I do not like i's, don't know how to work with them, so let's get rid of them. So the front stays the same, a times x minus 3. This turns to x squared minus xi plus xi minus I squared. So we have a minus xi and a plus xi, so that can cancel. And then our I squared, well, I squared is equal to -1. And then the negative of -1 is equal to 1. So we can actually replace this with a positive 1. So now we're left with a parentheses x minus 3, x squared plus 1. And now I'll just double distribute again. So I'm just trying to get this all into just like a bunch of terms that I can look at. So once I double distribute this, I get something that looks like a parentheses x cubed plus x minus 3x squared minus 3. So then just rearranging this just for my OCD, a times x to the third minus 3x squared plus x minus 3. All right, and what from here? Well, now we actually care about this f of 2 equals 15. Oop, wrong color. We care about this now. Because now we're going to plug this into our, always the wrong color, it is not following me. We're going to plug that into this and solve for a. So we're going to say 15 is equal to a parentheses 2 cubed minus 3, 2 squared plus 2 minus 3. So just doing some of the math, 2 cubed is 8. 2 squared is 4 times -3 is a -12 plus 2 minus 3. So this ends up adding up to a -5. So we get 15 is equal to a times -5. Dividing by -5, we get a is equal to -3. Now we plug that -3 back in for a and simplify. So we get f of x is equal to a -3x cubed plus 9x squared minus 3x plus 9. And that is all of those. That is all the review. Let me just grab all the factoring things that I wanted to talk about, and I'll add that right at the end. All right, so I just wanted to quickly go over a few of the things that you might see factoring wise, just so you have them in your brain, something that you can maybe write down on your paper while you're studying, just kind of keep it in your brain. might help you a little bit when you're factoring. So the first one, the most important one, you are 100% using this on the test, is a squared minus b squared. Difference of perfect squares. Please remember that that equals a minus b and a plus b. A trickier one to see that you might see is something that looks like this. A squared plus 2ab plus b squared. Or, very similarly, a squared minus 2ab plus b squared. It has to look like this. It has to have this format where the first and the last term are both some type of square, and then the middle adds up to either 2ab or negative 2ab. And these could be simplified as a plus b squared or a minus b squared. It's stuff we briefly went over. Do not stress yourself on these. If it's something you can remember and it just makes it easier for you to factor, great, keep it in your head. But if not, do not worry. The one that I would really remember, the one that you have to remember, is this one up here. Make sure you know your perfect squares. And that is really it for the review. It is short. Make sure you are focusing on these questions. Do the review. Go through your worksheets and find similar questions that are on the review and both your worksheets. Test it with different numbers. There's a lot of things that are definition based here, like that. Let me go back to it. Like that leading coefficient test, like whether something is a polynomial function or not. Those are stuff that there's not much math to it. It's really just remembering the definitions. So try to have those down, write like a little table for yourself. That's going to help out. If you have any questions on the review, hopefully this is posted by midday Wednesday. I'm just finishing up recording it Tuesday night. But I'm going to be on a flight, so I can't really answer questions as quickly. But you can always just like shoot me an email or shoot me a Canvas message if maybe you didn't understand something. And then all of Thursday, I'll be a little bit busy as well, but always you can just shoot me a message and I'll get back to you as soon as possible. But good luck studying. As I mentioned, do practice problems, do the review, look over your worksheet, just look over problems. They're going to be similar ones. So just kind of get these things routine in your head. It's a lot of methods. It's a little bit more definitions than the other tests, but I know you got this. All right, and see you on Monday.